gonna get started. Welcome everyone. Thanks for being here. We've got our EQC Environmental Quality Committee is here, and then we have a few new faces, which is fun to see. Thank you for joining us for our first speaker series in the Shoreview Environmental Quality Committee's 2024 Speaker Series. My name is Paige Alberg, and I am a member of the Shoreview EQC. The speaker series is one of two big events that the EQC hosts each year. So the other one is our Green Community Awards program, where we recognize people for doing projects such as improving energy efficiency in their home, adding native plantings to their home, doing different water conservation practices in their homes or businesses too. The application period starts in the summer, so watch for that to be posted on the city website. You can nominate yourself or a neighbor or a business that you see being a good environmental steward. Now, for tonight, I'm excited to announce our speaker. We have Jordan Wein, who is an environmental scientist with WSB, which is a consulting firm based out of Minneapolis that specializes in engineering, community planning, environmental, and construction services. Jordan will be talking with us about managing carp in urban waters. Common carp and goldfish are non-native invasive species that can have significant negative impacts on water quality of lakes and wetlands, and they can be some of the most difficult invasive species to manage. Jordan will talk through the history of carp introduction, description of their behavior, and what has been learned over the past 10 years of research and management. Turn it over to you.
Sounds good. Well, thanks, Paige, for that introduction. With your introduction, I think I can skip about half of my presentation because that's what, no, I'm just teasing. Well, thanks for inviting me here to talk about something I've been working on for over a decade from a few different standpoints as a researcher, as a student. It actually wasn't part of a master's degree program, but I was in a master's degree program and wanted to spend more time outside instead of inside a lab. It was just more my style. And there was an opportunity to study with Peter Sorensen and his Common Carp lab at the University of Minnesota at the St. Paul campus. They got me out in a boat, and I started doing electrofishing surveys, catching big fish out on lakes not far from here, and the rest is history. I couldn't not be doing that, and looked for every opportunity to get back into it. Took a hiatus to Ghana, West Africa, in the Peace Corps, and came back, and this was the first thing I looked at getting back into, and I was excited to have opportunities in the consulting realm to continue applying some of the things I'd learned and helped do research on. And it starts mostly with common carp. Paige did mention goldfish is kind of an up-and-coming issue that I've also been looking into. Happens to be a big problem around the metro area, as you can imagine. But most of what I'll talk about tonight will be common carp, even though a lot of it is very applicable. Same sort of conditions are there. So let me get started. So presentation overview. Some attributes of the common carp. You see common is highlighted or italicized here because a lot of times people will think carp, and the thing they think of are what's in the news at that time. And a lot of times what's in the news are silver and big head carp, otherwise known as generally as Asian carp, even though they're all kind of Asian carp. But specifically, we'll talk about common carp and why they're actually thought of as being common carp. What the carp's role in lake ecology, so how is it influenced? How does it influence the lakes or the water bodies they're in? Some mitigation strategies. In parentheses, it says reverse engineering. I think it's a fancy way of saying what can humans do to the lakes to try to mitigate and reduce the impact that these common carp now have on our waters. And then finally, a couple case studies, and then my preference is open it up to you guys to ask questions, and we can have some conversation after that. So to start, common carp profile. First of all, who's familiar? I feel like people are familiar with common carp. Yeah, okay. So they're around all of these waters around us. And they've probably, from doing this for over a decade, I hear a lot of people who have experiences with them, things they did as kids, how they caught them on what, and what they did with them, what their grandparents did with them, and what they ate, and all that sort of stuff. So they go back a long ways, but they are not. So first off, their scientific name is Cyprinus carpio. That's part of the carp and minnow family. So essentially, it's actually just a big minnow. if you can imagine that, but it's one of the largest species in the cypriniid family. It has pharyngeal teeth, so you don't think of them as having teeth because you think of teeth at the front of your mouth, but they actually have them in the back of their throat that actually is used to grind. It's basically they have molars, and if you dissected them out, they'd look like human molars. It's pretty interesting. They're omnivores, so it means they eat animal products as well as plant products. They're very opportunistic. They can be migratory, and that can be a very important part about what you learn about the fish in each system and how they are moving from one place to another and at what time and in what conditions. They're very tolerant species of a wide range of environments, so physical, chemical, biological, all these sort of things make it a really tough fish to be in any of our lakes around here, and even more so, they're long-lived. I think some people say, well, what's the oldest fish you've found out the age of? And I think it was actually in one of these lakes around here, we took it out and aged the fish to be over 60 years old. So I was also a part of a lake association meeting was said, well, if these fish, if they're not reproducing, can't we just let them die off? And then I looked at them and I said, well, some of these live to be 60 years old, so they might be living longer than you have a chance to see any improvement in the lake if you just let them die off. They can be very old fish as well. So backing up just a little bit, where do they come from? If they're not from here, where are they from? So they're native to Caspian Sea and the Aral Sea, the regions of Eurasia. Again, like I said, even these guys, if they're not known as Asian carp, generally, they are still from Eurasia. They were introduced to the United States in the mid-1800s from Europe by private citizens using the U.S. Fish Commission. So you wonder, well, what's the path of that? It was actually Eastern European immigrants who came across to North America, started to spread west, and they started to look for forage and food and opportunities and protein sources. And they found that they were used to having these common carp in their homelands, and they wrote back home and said, they don't have any here. Where are all the carp? This place would really be a great place for carp. Can you send some over? They said, sure. And we'll make you guys all happy. They shipped over a tanker of common carp, what is known as common carp, across the Atlantic Ocean. They landed, they loaded them up in, the Fish Commission owned some railroad cars, loaded up live fish and just started heading west, and every time they got to a big water body, they'd dump one of the cars out. And after that, you'll see here in the next few graphs that they did the rest. They are the third most frequently introduced species worldwide, of course, according to certain publications. So they're a very invasive fish. They cause lots of problems, and they spread everywhere. So you can see here indications of where they've been found across the world. Again, they're native, as you can see, to the hot spots right in Eurasia, but they are all over the place. Some of the biggest known places, of course, unfortunately, are a lot of North America, and then Australia is in a lot of the research papers. They've done a lot of work. Some places are even to the point where they could basically call it they've exterminated them in Australia, which is a huge deal. Very, very hard to do. In fact, around here, we don't even throw around that word. It's just not feasible. But Australia and some of those places, they've put so much time and effort into it, they may have actually gotten to that point. So common carp U.S. distribution, they're distributed in every state, including Hawaii, except Alaska. And part of that just happens to be about the geographical conditions of where these fish thrive and do well. You can see all those red dots are in places that are really well connected to tributaries, water bodies that are frequent to, at least from time to time, have high flooding situations where they can wash out into another water body. Even if most of the time they're not connected, life finds a way. One of my favorite quotes from Jurassic Park. You'll see here that they do, and then when they find their way in, they spread and they take over and they find a great home in all these places. So Paige mentioned about certain invasive species and what they're actually known as legally, and not just only as invasive species, but how are they legally known as in each state. So by the USGS, they're listed as a non-indigenous aquatic species. In Wisconsin, they're listed as a restricted invasive species. In Minnesota, they're listed as a regulated invasive species. But regardless, they're all an invasive species, things that are not originally from this area, and they're causing damage to the waters and anything they get into. And so that brings mostly to the point that I bring up with my clients and to lakeshore residents, cities, anybody I work with and for, is generally the thing that they're concerned about is managing carp for the impacts they have on the water quality. And that can be really broadly defined, but a lot of times it has to do with managing nutrients, managing aquatic habitat, and just the fisheries in general. And carp can have a negative impact on all those in a really, really large manner. So some things to mention, there's an increase in internal phosphorus loading. The P stands for phosphorus, if that wasn't obvious, through excretion. So, everybody just says pooping, and foraging, spawning behavior. So they churn up the bottom of the lake. And usually what happens is, as you'll see in a slide coming up here, they reinvigorate phosphorus that a lot of times is living in the bottom of the lake. And if it's living in the bottom of the lake, it's generally okay for water quality in the water column above it. But as they are rooting around in the bottom of the lake, they are actually bringing it back from the lake sediments and putting it back in the water column, which then to the second dot on here says it leads to a decrease in Secchi depth. That's a disc that goes into the water to give us an idea of how clear the water is. So an increase in Secchi depth means it's clear and I can see it from a long distance from the surface of the water. And chlorophyll A, that's basically just a measure of green in the water, which is then a measure of how much algae is in the water. So all of those things are measured on a really regular basis on all these watershed districts, and whoever is basically in charge of keeping tabs on water quality around here in Minnesota. So they're looking for clear water, low chlorophyll A, so not much algae in the water, and also low phosphorus as a nutrient in the water column. And these are amplified in shallow lakes because this turnover is mixing the water all the time because there's not a splitting in the different layers of a lake. So shallow lakes in particular are affected even more so by common carp. And most of the lakes around here, generally as a limnological term, are considered shallow lakes that common carp have problems with. So like I said, here's a nice little image of common carp and how they have negative impacts on the lakes and water bodies they're in. You can see here a couple of our icons. The P all over the place are little pockets of phosphorus, and most of them are located, when you look in the lake, are located in sediments. They're around plant roots, and that's where common carp do their worst on the lake. Like I said, they're rooting around in the bottom for things like little worms or invertebrates or seeds or crustaceans that they can crunch up and eat. They don't really eat from the water column, which is actually one of those things that differentiate common carp from silver and bighead carp, the Asian carp, because those guys are actually filter feeders through the water column. So they feed in completely different areas. They don't really have the same impact, actually, besides both impacts being very negative between those species. The other one is you can see the spigot coming into the lake where it's pouring in phosphorus. So those are kind of generally known as the internal phosphorus load and the external phosphorus load to a sampling area like a lake. And where we come in is trying to manage the internal phosphorus load by reducing carp impacts on the lakes. So if we take these guys out and manage them and keep them from coming back, hopefully that phosphorus stays where it's at, is less mobilized, and doesn't have as bad an impact onto the water quality. So again, some of the things I mentioned, carp impacts in concern of vegetation is also a problem as well. You'll notice that it says negative relationship between macrophyte abundance and carp biomass. It means basically as one goes up, the other goes down. And you'll see that it's kind of, you can imagine the negative reinforcement cycle that common carp have to impacting our lakes in a negative way, because aquatic plants are a good thing for a healthy lake. It may not be the most fun to have in your lake, filling up your lake, if you are, say, a water skier or an avid boater or something that wants kind of open water. Carp will definitely do that for your lake, but it will also change the lake in the sense that it will make it very turbid and brown because it's resurfacing a lot of sediment that's locked in the bottom, And in that sediment, it's also releasing that phosphorus, which turns it green. So you have maybe no weeds to swim around in to have to deal with, but you also have green and brown water with probably not very good habitat for fish that you might want in your lake. Density dependent, SAV stands for submerged aquatic vegetation. More impacted than emergent or robust floating leaves. So floating leaf species are duckweed that covers the surface. And emergent are like bulrushes and cattail. So submerged species in particular are more impacted by common carp. They get in the bottom, they pull up the weeds, and they keep them from re-rooting. And you can imagine kind of as in a mindset of an erosion effect that aquatic vegetation has on the lake bottom. It holds it in place. So that also keeps that phosphorus from coming back up into the water column. But if they're not there because of carp abundance, then that can be a problem that's really hard to fix and change back to a clear state. That's what you see here. This is a picture of a nice, healthy ecosystem in the ecology of a lake. Clear water, submerged aquatic vegetation, and if you had an idea of what was in there for healthy fish, it would probably look pretty diverse, well balanced from top to bottom. So elevated carp biomass, for one example, about 398 pounds per acre is sometimes some of the levels we see. That's about 4 times the level that common carp should be below before you start seeing really negative impacts on a lake. That resulted in a 71% loss of northern wild rice distribution on Clam Lake. So this is Tony Havranek, his data when he first got into common carp management. He was trying to reestablish wild rice paddy beds for a St. Croix Chippewa tribe. And he realized the one big thing that was keeping them from reestablishing those wild rice beds was so many common carp in the lake were just churning it up. And anytime they would start to get reestablishment, the common carp would just rip it back up again. And once they remove the common carp and keep them from coming back, keep them from recruiting, they saw those wild rice beds come back. So impacts on the fisheries. You have a reduction in habitat. So as they're uprooting these aquatic plants and the food, the macroinvertebrates, the little animals that are living within the plants and the weeds in there, this can result in reduced game fish and panfish abundance, diversity, and size structure. So generally, they're just not as healthy. Things like bluegill sunfish and perch and minnows and other things that are kind of that bottom of the food chain in the fisheries that we kind of identify as being good Minnesota lakes. Common carp can take out everything that they need to survive. It may not actually directly impact them by actually eating the fish, but they make it so they can't really survive very well or be abundant. And so this is just another, several papers have noted that an inverse relationship between a relative abundance of native fish and common carp across 81 lakes. This is in South Dakota, specifically black crappie, bluegill, white bass, and northern pike. So just when you want good fish, you don't want common carp. So wow, that's pretty bad news. And that's what you feel like is just, what do you do? Man, you just threw out a whole bunch of carp are horrible and they're everywhere and they're abundant and they're huge and what do we do? Is there any hope? But as Paige mentioned, new holistic approaches, and this is a relatively, these new holistic approaches are somewhat have been put into practice now for about a decade since some of these really well-researched and tested methods by the University of Minnesota through the Minnesota Aquatic Invasive Species Research Center has really promoted these and made the tools available, that has made it available for things like consulting companies to take them on and use those as tools that can be available, not just to have a research student come, but say, hey, we've learned a lot about these things. Can you come in and figure this stuff out? So it's great because someone who's really excited about it and really wanted to focus on it had a place to do it as a career, and that's why I'm here. And they give opportunities to not only enact long-term carp management, but also put a plan in place to think about this as not just a couple few years worth of work, but making sure that they don't come back for long-term management. So this is kind of, we've put together a mindset of integrated pest management, and specifically carp integrated pest management. Integrated pest management isn't really like a new concept. It's been used for mice and cockroaches and all kinds of things you want to get rid of. But they all have their kind of ways of figuring them out and doing something about them. And we've put this graphic together to really sort of start the conversation with clients or anyone who's looking to approach a common carp research or management program, as it goes through about these 3 phases generally. Phase 1 is baseline data collection. You have to find out how abundant are they, so what's the population, where are they moving, how do they move around, what is the lake condition right now in certain native species that can keep their recruitment from coming back. Things like native fish, bluegill sunfish are really important to that. Aging, finding out how old they are or how many classes of fish are coming out, common carp are coming out from your watershed district and your area. And then habitat, what's the lake look like right now to promote native fish from coming back or vice versa to make it a really good habitat for common carp to thrive. Phase 2 is the most heavy burden on this. So once you kind of find out the information of what you need to do, you put together a plan, and now it's time to do the plan. So that usually generally takes several years of physical removal. So that kind of is a lot of times what makes the headlines of these big piles of carp being pulled out, which is obviously very important. But you need to also put some kind of barriers to potentially prevent movement of these fish from one place to the next, because usually they're going to places that are functioning as nurseries that they can take advantage of that don't have an abundant native fish population. Biocontrol, so how do we keep these native fish in abundance and in good balance that can keep them from growing and thriving. Outreach and education, believe it or not, there's still people who think that common carp can be introduced to places that you want them, that they're good for the lake. They take these weeds that we don't want in the lake out, and just really understanding what common carp management can have on your lakes. And then habitat, thinking what can we do to the lake to make it more, basically push the effort toward native fish and make it better for them so they can thrive and do their part to keep common carp from thriving and coming back. And finally, once you've really starting to see the impacts in water quality parameters, you can kind of step back a little bit and really gear down on your effort, and you just keep an eye on things. So once you've got the population down to a manageable amount where they're not significantly impacting the water quality, you keep an eye on, do they ever have a good recruitment class? And that means, do they ever spawn a whole bunch of little baby carp and they're all surviving and now the lake is back to where it was? Are we seeing that they're finding new movement patterns that will get them to places that will help them spread? How is the rest of the lake in biocontrol, meaning how are the native fish responding? And also to take another look at the aging to see if any new carp classes are coming in. And finally, just always keeping an eye on habitat. Now, at this point, some of that native submerged aquatic vegetation is able to reestablish, provide habitat for native fish. This is kind of the things that we would be monitoring as common carp management is going. And there's lots of thresholds that you can keep an eye on to let you know if your management plan is working. So bioengineering using IPM, Integrated Pest Management. So I mentioned in the news and a lot of research papers, Australia, this Murray-Darling Basin has a really strong reputation for focusing on common carp and how important it was to them. As I mentioned earlier, MyCirc has pioneered a lot of tools that have been made available and also learned a lot about their genetics and their population dynamics. And then eventually, that was, like I said, made available to research. That research was made available for lots of projects from WSB or other consulting firms around here or around the other states, and they're being able to be put into practice. So that's a really good thing. That's what you would hope that research actually does. Your tax dollars to learn things about it, actually made available to do something where you live. So yeah, applying this IPM, we're at the data gathering spot. The first thing you'd want to see is, are there a lot of carp? Because a lot of times you'll see bad water quality, and it's not always because of carp. So you go and you find out, you kind of make a decision point of, yes, you have too many carp, or hey, there's actually not that many, and your problem is something else. And then you look at, can they be captured? What kind of opportunities can we have to get rid of these fish? And you also look, number two, how many are there? Are there predators? And by predators, we're generally not talking about big fish or eagles or osprey or anything like that. Generally, you're talking about the predators of their eggs and larvae. Just these first basically 2 weeks after their eggs are fertilized in that spring spawning time. And those predators generally are small fish like bluegill sunfish. So that's a good indicator of a potentially resilient lake that could defend itself from having those carp come back at you. And then age and size structure. How many different number of classes of ages are there out there? And that will help you make some management decisions. So how do you answer some of these questions? With fun tools that we get to use every day. It's always a good time. You see on the top left, we go and we'll put radio transmitters inside carp. So we'll go and capture carp with this picture on the top right here. That's an electrofishing boat. So what that does is it actually sends out electricity through those arms you see hanging off the front. And there's a control box behind Mary in this situation. She's controlling the volts and amperages, and it's basically sending a giant taser into the water in front of the boat. It works about 4 feet on either side of the booms and about 4 feet down and about 4 feet in front. So basically you just slow cruise around the shoreline where you'd frequently see common carp kind of moseying around and foraging. And when they are within that field, they get immobilized and pulled up to the water surface, and you dip in, you scoop out. I always tell people I feel like that if I just did that for 8 hours a day, every day of my life, I think it'd be cool. I'd just electrofish all day. But what Tony's doing here in the top left, we caught some of those carp and we actually anesthetized them and we put radio tags inside them. We put a little incision in their belly and we slide in. It's about the size of a roll of nickels, and then it has an antenna coming out the backside. And then we walk around with a receiver tuned exactly to each individual fish, and we can locate, eventually we can go toward it and find probably within about 100 feet of exactly where those fish are. And that helps us tell, especially, you can see he's out in the wintertime. You're saying, what do you care about in the wintertime? That can actually be, as you partner with commercial fishermen, that can be the best time to actually go after common carp because that's when they are aggregated the most. You think of minnows and they actually get together in what we call shoals. These guys do the same thing, and when they're all in one big pile, you can target them more effectively. And if it works well, then you get them all, or you get a lot of them. Then you think of binary or biological control. Part of this is like chicken or the egg, which comes first, which one do you hit first, what do you do before, do you remove or do you introduce some of these other things that can make the native environment better for native fish. But you can see here, this is the habitat part, introducing what we call coarse woody debris. If anyone's fisher people here, that can be a great place we want to go and target right out in front of those. Put your live bait in front of those guys because that's where they can hide, they can find some shelter. And the far picture on the right is actually stocking with some native fish that you would want in the lake if you find that they're in low abundance and you want to bring their populations back up. Those can be biological control options for bringing the lake back up. Barriers can also be an effective tool. They're abundant around here, and you may stop native fish, but if it's most important to see on the top left, this is out in Prior Lake. A couple of these pictures from that. This was from Clam Lake in Wisconsin. Basically just stopping those fish from getting to places they want to go. And that can actually make it an opportunity for removal as well. I think this picture, about an hour and a half after that, we came over with the electrofishing unit and just dropped it right on top of them and took about 400 out just sitting right there. So, and then the top right picture is what we call a velocity barrier. It's not really something that's stopping them, but it's the flow of the water goes so fast that they aren't actually able to make the trip up and make it into places that they want to go. And then, like I said, physical removal. This is the pictures that are tagged to a lot of common carp management programs. This is the big success. This is when you call in these very colorful languaged commercial fishermen who come in and do their job that they've been doing for 50, 60, 70 years. And they send a big, if we go in and we locate a group and tell them it's right here, avoid this spot, watch out for here, it's about this depth, they can go in and put in about 3,000 foot net around this group, pull it out from the other side, and they swoop that net around them and scoop them out from the inside. And then actually a sister company of WSB, who I work for, is actually the logistics company that actually moves those fish to market. Believe it or not, they get live tracked and sent out to usually New York, where there's a buyer for common carp for human consumption. and that makes it so it's actually a sustainable loop there to keep this going and keep it so that there's a reason to continue rather than just taking these. I think this was probably about 70,000 pounds of carp that was caught here. So what else are you going to do with them unless you send it off to be used for something? And this is a video, it's like a minute and a half, but I always find that the links never really work out in presentations, so I'll just skip over it. But some case studies. I mentioned my supervisor, Tony Havranek. This was his big first marquee project that he got started with working for the St. Croix Chippewa tribe in Wisconsin. And this lake, they really wanted to, like I mentioned, bring back wild rice for heritage and for their foraging and everything. And the initial estimates said there's about 80,000 actual individual carp in this big lake. That's almost 800,000 pounds of carp, only on a 1,400 acre lake. So it was just chock full of carp. And that was clearly, as they got into understanding that, the problem. So you can see here that they were taking estimates as they were trying to get after these guys, and they just really couldn't make a giant dent until it was between 2013, I think it was 2014, was when they had this big pull, and they hit about 500,000 pounds of carp in one haul. But you see, it took them about 7 tries, I think, 7 years from the beginning to get there. But after they hit that, they went back in and took biomass estimates, and it dropped down to far below what the management threshold is. And to give a little context of that, that's basically an idea of how much carp mass per acre of lake. If you get above a certain level, which is generally about 100 kilograms per hectare or about 87 pounds per acre of carp, if you're below that, you're really not seeing that they're that impactful to the lake. And at that point, it's probably not worth your time and effort and money to go after these guys. But if it's above that, they are probably having a big and negative impact on the lake. And so you can see here it was far above that every time they went out and took a look at the fish. And then once it got to here, it's far below. And that's where they wanted. They saw wild rice paddies come back. TSI values, that's just another value for health of the lake. Kind of looking at all those 3 parameters I had talked about earlier with algae in the water, abundant vegetation, and good things in the lake. So you can see that those were really following the carp biomass drop. And the pictures of the lake, this is just easy before and after. And for some people, as you look at this, it's like, oh, that's not, some of you might see that's not great. Oh, that's horrible. Maybe, again, if you're looking at recreation, that can be problematic. But that's a big education opportunity to have with people who are wanting a healthier lake, but also be able to go jet skiing and boating and all these things. In shallow lake situations, it's really tough to have both. So on the right is a much healthier lake. Another case study, not far from here, Silver Lake, right over in Rice Creek Watershed District. It's a much smaller lake, 72 acres, but it did have some depth to the lake. Lots of shoreline that was developed. There's a big park around it. A much smaller number of individuals, about a little over 1,000. But that was 9,000 pounds of carp. And you can see that their metrics, the things were just not in good shape. If you see total biomass was way over where it should be. And they were seeing issues with that. And so they went after common carp. And again, if you're looking at the main things for water quality, you want it to be, you actually want the numbers to be deeper. But as they'd see, these numbers really reflected carp biomass. And actually, when they went in to do something about it, was right here between the 2015 point. And you can see that the water cleared up a lot. You could see deeper into the water. And then the problem is, if not everything goes really well and you're not having all your T's crossed and the sustainability is set up perfectly, they can come back. And you can see that the water clarity did decrease. And with that in mind, I think there's actually some work in the progress to get this project back going again. And this is just a measure of through the years. Each one of these kind of go through the years. Different aquatic plants, you can see, get more abundant. And then as the carp are starting to come back, they start getting less abundant as the years go by. So you can see that their impact is pretty well linked to all of the carp abundance. So in summary, I kind of went over history, what their impacts are, where they came from, and why they're a problem. elevated carp biomass. It reduces clarity in the water, it reduces aquatic vegetation in the water, and it increases total phosphorus. That's the nutrient that's basically like Miracle-Gro. For chlorophyll A, that's the measure of algae in the water. So all of these are really impacted by carp. And it affects the fisheries, wildlife, because that's habitat, that's food for ducks. I know that's a lot of where some of the research was started from wildlife refuges that were seeing a decrease in duck abundance because carp abundance went up and the lake was a big problem. And then implementing carp integrated pest management plans. They came about to mitigate and restore the lakes through data collection first, limiting recruitment. Again, recruitment is just if a little baby carp egg survives and grows for a couple years and once it gets to that point, they are essentially like recruited to the main population. And now they are one of the big fish in there and they don't really have any predators after that point. So you want to limit that. You want to remove the adults because those are the ones that are actually churning up the bottom of the lake. And then want to working on habitat to improve it so that native fish have what they need to become abundant again and keep carp from having as much of an impact. So with that, there's a lot of information, and this is my favorite part. If you guys have questions or comments, I'll let us just have the conversations about it.
So if anybody has a question or a comment, just for the recording purposes, we ask that you feed it into the microphone so it can catch that. And then whoever has anything to say.
Thank you for your presentation. Question about woody debris and where you place it. Do you get landowners that are okay with that? Because I would think some would be not okay with that. Are you looking for public land to do that?
Yeah, it's a great question. There are some good places, there are some not good places, and interacting, Minnesota and Wisconsin and places around here, we use our lakes. We're on our lakes. We live on the lakes. And so yes, having community meetings with places you are going to plan on doing any kind of work on the lake, whether it's just taking carp out or if you're going more into introducing some root wads, we call them, or some down to trees. That can be a problem for some people's lakeshore, and they're not a big fan of it. But it's looking for opportunities to try to do both. Maybe find opportunities where it's not fully developed, it's not somebody's backyard, or in between lots, or finding empty lots, or sometimes it's just not, it either already has plenty of woody debris, places, habitat for fish in there without touching it, you just kind of want to keep it in place, or it's on a lake that isn't as highly developed and you just look for more opportunities to introduce those. So yeah, dealing with shoreline owners is just a part of this management work. And so that would be an example of how you'd have to have somewhat of an agreement and understanding of what's the pros and cons of making some of those management decisions.
Hi. Do you have knowledge of carp numbers in Shoreview lakes?
No, not exactly. And it's interesting you say Shoreview lakes because what lakes are technically in Shoreview? I'm more understanding of watershed districts. So
Turtle Lake,
okay.
Snail Lake,
Owasso, okay. Okay. So those are Shoreview. Okay, good. Yeah, I don't know up to now where those populations are, but definitely. So Ramsey, Washington Metro Watershed District, of which who Paige works for, they've had one of the more successful carp management programs in the metro area. I think a lot of people look to that group of seeing how have you done it, what things have you tried to do. I mentioned right off the bat, some of those projects were done in the Phelan chain of lakes, which is Keller Lake and Jarvis and those ones. But within that watershed district, we also moved over to Owasso, Wabasso, and in that chain as well. They were pretty high when I worked on them 6-7 years ago. I think consultants were used pretty heavily to get that under control. And then I think it's also been somewhat embedded in their natural resources groups workforce to say you will be doing some stuff or a lot of stuff with common carp management. Those ones, I don't know. Maybe Paige, if you could talk to the population levels at this point. I
Yeah.
know it's much lower than it was before, and some of those impacts are really being seen.
Yeah, you covered it nicely. So I do work for Ramsey Washington Metro Watershed District, but not with the carp program. So we do have a natural resource program that is out doing carp removal. We do a lot of it in-house, and then we're with another consulting company too to help with that, as does Rice Creek Watershed. So if I can give you my card and I can give you a little bit more detail, but we do have some, are they bubble barriers? Is that a thing?
Yeah, bubble-
In
they're-
Owasso, yep, to help with that movement. So those were put in last year or the year before, I think. So we check those and then do some of the removal as, not quite those large numbers. We've done some of those winter seinings and things that Jordan touched on, but some of those as the carp kind of build up on those barriers, taking those out in smaller numbers. But yeah, it's a constant work in progress. Yeah.
Yeah, actually, Ramsey Washington Metro Watershed District and then their neighbors, Rice Creek Watershed District, are probably two of the more pioneering, I would say, to adopt a lot of the research that had come out and put it into practice and put investment into knowing that carp management should not be thought of as projects where it's going to be a year or two to get this under control, but saying we're going to make this a part of every year's effort from our natural resources and our water resources groups and folks, and we're going to have consultants kind of on call and saying, what are we doing next year? What did we do this year? How did it work? Because it's a long-term sort of thing, and that's just what invasive species management is. But yeah, Rice Creek, so Long Lake over by New Brighton, that was like the home base for just a whole ton of big carp, and they would make their way up Rice Creek every spring, and they would make their way into shallower lakes, and they would spawn, and then all those fish would survive for a couple years, and they would all just come back down. And so it took probably millions of dollars and years, probably about a decade now of effort to really get those under control, and it's taken about that long to start to see some of the actual impacts on the water quality and the health of the lake to start coming back in these last handful of years. But yeah, a couple big names are around this area. So.
Thanks. I have a couple of quick questions. One, how do you estimate the numbers? And then also something about what you just mentioned, how far do they travel on their own from their different grounds?
Yeah, great questions. The first one, like I mentioned, is probably my favorite part of the job, is doing electrofishing surveys. That was, again, a method that was developed through that Carp lab at the University of Minnesota, using basically the rate of how many carp you're catching per hour of doing this electrofishing thing where you're just looking for fish and you've got the electricity on the water. And say you catch 6 of them every 20 minutes on different parts of the lake. You take the average size of those fish, you take how many you caught per hour, and you do some math and you say, your lake, on average, the fish are this big and there's this many per acre and you've got this lake of this size. That generally says your population is about this. So there's a little bit of math based on how many fish you're catching per hour of doing electrofishing. That was a big moment because that was kind of a quick and relatively inexpensive way to start estimating the populations, because other options are very labor intensive and they take a long time, but they're more accurate, called mark and recapture estimates, where you go in, you catch a bunch of fish, you do like a fin clip. One of the pictures I showed earlier had like a really wonky looking fin clip on that. It's because it's a fish who grew back a fin after we'd cut part of it off. And you can release them, come back later, catch them in a large number and see how many were marked from the previous time and do some statistics and all that, and it spits out a number about your carp population. And then how far can they move? They can move up to 5 kilometers a night. One of those in the Rice Creek Watershed District had a student actually that would go out and do telemetry on, I think it was 20 different radio tagged fish every 2 hours for 24-hour periods. So literally at midnight, he's boating around the lakes looking for these fish. And he would find that he would catch them. He would detect them at 8 p.m. In one lake, and then he'd find them 5 kilometers upstream the next morning at 6 in the morning. So they're very powerful and probably one of the more powerful fish that you'd see around here. But the question is, do they move that far? Sometimes they do, in the case of Rice Creek. Sometimes their nursery lakes or ponds are just next door, so they're not too far, so they don't really have to go that far. But the ability to go that far is definitely within their capabilities. So I think Peter Sorensen, Dr. Peter Sorensen, one of the main guys who started a lot of this fisheries research stuff, and he's still in the news for, I guess he got bored with common carp and moved on to silver and bighead carp before he retired. He basically said, if a drop of rain falls, a carp can move through it. It just seems that way. It's just, whenever there's moving water or there's any opportunity, they can even flop across the mud sometimes to get to new places. So that makes them very problematic and really hard to stop.
Any other questions?
Look at that, 45 minutes on the dot.
Nice. Very
Good
good.
for me.
Yes. Well, thanks, Jordan. That was great. Oh, do you have a question?
So evidently the carp protein is popular in some parts of the country. So is there any chance of fish and chips with carp here? I mean, is there any, could the popularity of eating carp be a factor in reducing them?
Yeah, it is. So that protein source, a lot of it's also linked to cultural heritage. This is an interesting thing. If you get bored, look up on YouTube or any kind of, Google Christmas carp. And that'll tell you the story of Scandinavians and Eastern Europeans, Ukrainians, and kind of that whole area where these are native to. That's where they've always had them for hundreds and hundreds and hundreds of years. And they would actually capture a carp or get a carp, and they would keep it in a bathtub for weeks to let it kind of metabolize and like clean up the meat a little bit, and then they would slaughter it right over Christmas. And so now, like I said, those fish that we're catching in the tens of thousands of pounds at a time and shipping them off, they're kept live so they can buy them live. So that's and kind of go through this culture. Taste-wise, one can argue that there can be dishes that are made with common carp that are tasteful, but it's not as popular around here. So generally they leave our state and go to other places where they are desirable. But it mostly surprises people that they are turned into for human consumption. But the argument could be that if some of those cultures are starting to dissipate and not be as an important driver rather than just taste of the fish, if that's not the driving factor, then there could be a decrease in demand for common carp, and that could affect some of the opportunities we have to move these fish to useful areas.
Those fish that jump out of the water, those are carp, aren't they?
They're called silver and bighead carp. They are carp, yes, but yeah, there are big differences.
Do you have anything to do with those?
Whew. I'm going to say right now, not yet. But you see in the news, a lot of the commercial fishermen we work with a lot, I've worked with several of these guys for almost this whole 10 years. They are the main contractors for the Minnesota DNR. When you see headlines that say, oh, there was 50 or there was 10, or I think just recently there was over 300 silver carp caught in the St. Croix or the Mississippi in different pools that are downstream. They're just barely into Minnesota waters. They are not far away. So currently, what we've mostly focused on are freshwater lakes, inland lakes like we see here. Silver and bighead carp, they do well in bigger flowing water bodies, but they can find their way through some of these floods to find their way into inland waters. And then they can be really problematic. If you think weeds are a problem for recreation, put in 50,000 pounds of silver carp that are 15 pounds apiece and jump 6 feet out of the water as you're boating by. And that has happened in Nebraska. We've had a couple projects where we've gone down to some lakes, some sand lakes off the Platte River, where that's happened. They had 200-year floods in the same 10 years, and then they had about 60,000 pounds of those in about a 150-acre lake. So that was a big problem for them.
Hi, thank you for presentation. And when you talk about use of food and taste, actually it's not big deal. When I was in Europe, and the carp, smoked carp is very popular, very delicious. But to me, mostly I'm concerned here is mercury in sediment. When you talk about food, I know the local in Minnesota, some mercury in sediment. When the carp eat sediment, they accumulate a lot of high concentration in the mercury. So this is what's really concern for people, I think.
Yeah, that's a very fair point, and that gets brought up a lot. A lot of times, actually, as people find out that Fish 2.0, this other sister company of WSB that is bringing these fish to a market, they can be really big fish. And as a fish gets bigger and bigger, the bioaccumulation of heavy elements like mercury are a big concern. So that testing is done by the buyer from Fish 2.0 to that point. If they have any food grade testing that needs to happen with that, that happens before it gets to a consumer. But yeah, if people around here are just angling for fish and they're catching them, if it's a big one, it might not, only for if you're not a big fan of the taste, it could be concerning for the heavy element inside that fish tissue. That's a fair concern. And you mentioned smoked carp. That's of the different 4 different varieties I've had common carp before. That's been my favorite, smoked carp. So that's probably, on average, a Minnesotan's favorite way to have common carp that I've talked to, at least.
I have had it that way.
Yep.
Yes. We did a staff cookout one day. I think so. There was a lot of mental issues that went along with it, but I think it tasted pretty good. Any other questions? Might as well wrap up, and Jordan will probably stick around if you think of anything before he heads out. But thanks again for coming tonight. We appreciate you being here. Please join us next month. I think it's the 26th, when our very own Tim Pratt will be talking about recycling, giving you some fun tips and helping you solve some mysteries of recycling. So come back for that at 7 p.m. next month. Thank you.